Really quick, I want to go over. Well, that's not going to get me anywhere. Really quick, I want to go over a data layout. That 2048 texture we're going to have, the big one, it's going to be subdivided into chunks of 512. And this is kind of like a texture atlas, but we're going to kind of like roll our own texture atlas. So the levels will be these 9 levels loaded at any single time in the world map, and you'll always be in the level in the middle, right? So when we're in this room and we move over to the room on the left, all of the data gets like shifted over, and then we reload the empty rooms, right? So if you move over to this left room becomes the new center. And since the left room is now the center, like all this data here gets shifted over here, and all this data gets shifted over here, which means this data gets dumped, and then we'll have an empty column over here that will load with the new rooms that need to be in the loaded into the world map, so they're ready. Also, this is going to enable us eventually in the far future to be able to zoom out like this, so we don't. Not only do we see the room we are in, but we can see this many rooms out. So I'm not gonna. I don't even know how I would. I mean, there's probably a lot of clever ways you could like pre-render things, but we're only gonna support zooming out this much. So you can always kind of get a bearing of where you are in the world by kind of like seeing what your neighbors are, you know. But I don't really have a clue of how to zoom out any further than that and still be efficient and lean with my data usage, so I'm just going to stick to that. Also, the way I have my rooms connected, I'm going to have these are kind of like default rooms. This is a horizontal connector, and this is a vertical connector. And the reason for that is I don't want these. I want a little bit of delay when you move from this room to this room. So when you move from the top left room to the top room, there's going to be like a hallway, and that'll be this vertical room, which will always be the same, right? So when we move from here to here, you're going to have to go through the hallway first. And when you move from here to here, you will also have to go through the same exact hallway. We can probably add some type of flair to make them slightly different. Same thing with here. So when we go from here to here, we're also going to go through a vertical hallway, and these hallways will give us a little bit of leeway to, like, when we're wandering through the hallway, we can start doing our shifting around of the data and dumping rooms and loading rooms from the world map. So any like fetches of data off of disk, we can kind of like optimize. Now I don't know if I'm going to be able to pull that off in JavaScript, but I'm still going to program as if I could pull that kind of fetching of data off of disk. And, you know, once we get to the point where I can no longer, where I've hit the limitations of JavaScript, we'll start like transcribing this into some C code. So GAM here is for game data, and I've kind of like, so you see this little arrow down here, it goes to GAM for the game data, and this is, whoa, look at all that. So basically what we're going to do is kind of like subdivide everything into chunks, starting at a chunk of 8 pixels by 8 pixels. And we will have, these are like general use, like I don't know what I'm going to use them for. Then I'm also going to have like these 3 areas of 16 by 16. I might just want to make this chunk like completely linear. I don't know. I don't know. I think reserving anything smaller than this doesn't make any sense. So we have all these chunks. So we could call this like 16.1, 16.2, 16.3, 32.1, 32.2, 32.3, right? 16, 16, 32. Yeah, and then, oh yeah, so I have this wrong. This needs to be a 128, and this needs to be a 128, right? And I'm still wrong, right? Okay, so 32. 32, 32, that's a 64. So these are all 64s in this subdivision. 64 and 64, that's 128. Okay, so this is a 256. My bad. So 256. Okay, and that would equal to 512, so we don't need this, so that's wrong. Okay, let me look at this over one more time. So 8 and 8, 16. So this 16 and 16, that becomes 32. The 32 and the 32 becomes 64. So this block here is 64. 64 and 64 is 128. And these two 128s, 128 and 128 is 256. And then 256 and 256 would be 512. Oh, okay, yeah, so that's correct. Wait, no, hold on. So, oh, okay, I see what I'm saying. So I'm trying to say that this block down here is, okay, that's what I'm doing. Okay, so this is the whole thing. This is the whole thing, and it is 512, and we'll use like a 512. There we go. Okay, so that's what I got wrong here. So this whole 512 area, and this is how it's partitioned, right? So, right, and once again, 256.1, 256.2, 256.3. You know, some way of address. We need some way to address these, or think of these conceptually as different address spaces, so that when we're trying to like reserve sections of memory, we can, you know, document where they're going to be, right? We could, well, I think that's what I'm going to stick with for naming these. We could also give them maybe more, like a more human readable name when we decide what we want to allocate in these different sections. Like, I know right now, like, the first section right here, this 8x8 section, right, that's 8x8 pixels, that's 64 different pixels. I'm going to use that for uniform allocation. So I'm going to try to basically have all of my data as unsigned integers. So no signed integers, no floating point, just all unsigned integers. And if I need to encode something besides a unsigned integer, too bad. We'll figure out how to encode whatever data, right? We just need the data. We need to get the data back and forth from the GPU to the CPU, right? We got to be able to do that back and forth. We're just going to keep it simple and just always use unsigned integers. If we need to interpret those signed integers as something different, we can figure that out, right? Because in the end, all numbers are just a sequence of bits, right? And so an unsigned integer is the least abstract of your data types. And so that's going to, for me, that's just easier to conceptualize if we kind of like tear down, you know, a few layers of abstraction. Might be convoluted to you, but that's the way I'm going to do it. And I just wanted to show you this diagram and give you an idea of kind of where I want to go with this. And I'm probably going to dump this diagram into the source code as well at the bottom, so I kind of have notes on how I want to use things. So rather than using, I believe it's a uniform buffer object or a texture buffer, I'm not going to do that. I think I'm not even going to use a texture atlas. I'm just going to use the texture in this kind of way to use it kind of as a uniform. And the reason for that is then I don't have to worry about running out of uniforms. And also, I'd like to keep it as simple as possible. So, I don't know, maybe I'd have better performance if I try to look at these uniform buffer objects and texture buffers and whatnot. But it seems that GL text subimage for like updating a subsection of a texture is pretty efficient. So I'm just going to stick with that. You know, and maybe it's not the most efficient way to do it, But for me, it seems like the most straightforward and simple approach. You might not think it's simple, but the idea is that it's simple because I'm reducing the amount of ways that I do things in code. So I don't want to. Right, what's that thing like? To hammer everything's a nail, right? Well, that's kind of also a simplistic way to think of things as well. It's easier to if you can conceptualize everything as a nail, then it takes a little bit less mental processing power. So I just really want to conceptualize all data as just pixels, right? That's kind of what I've been going here for with all these tutorials, right? I've been conceptualizing the tile values as pixels, and we will also conceptualize the in-game data as pixels as well. And the other advantage of this, if I make sure that every single uniform and every single piece of data in the game is actually corresponds to a texture value, then if I want to save the game state, I just have to take a snapshot of this one master buffer, this one master texture that has everything in it, and then we're good. Just save that, and you have the entire game state persisted. So I have these different tile sets. So I'll have 4 different tile sets loaded. You'll see 512 by 512. So I'm going to have some special encoding for how I do these tile sets. That's why there's so much memory for these tile sets. And then like game state, like maybe you have where the player is and the health of the player and whatnot. That'll all be in this 512 by 512 block in one of these subdivisions somewhere. If there's like maybe lighting could go in here, I don't know. But we're gonna constrain ourselves to this because this is plenty of stuff to work with, and we are gonna keep a very rigid structure. And I know that, yeah, well, a lot of people might be scared here because, you know, I'm taking away a lot of flexibility, and maybe one of the things you like about code is flexibility, and you're looking at this and you're like, this is not Scrum, this is like some waterfall bullshit right here. Well, you know, this is how I do it. This is how I'm going to do it. I think that, you know, I went to art school, and one of the things I learned in art school was, you know, you have to, when you're creating a piece of art, a lot of times it's those constraints that you set that help you design something awesome, you know? So you say, you know, what's a good example? You know, like maybe you want to say, okay, I'm gonna design a table, but I'm only going to use squares and right angles, right? Or I'm gonna make a table, but I'm gonna design it with nothing but isosceles triangles, right? And like adding some type of like absurd constraint can give what you're working on a necessary structure to create something coherent and impactful. Maybe none of what I am saying makes any sense to anybody, but that's what I'm going to go with. And we'll see in the future if this goes anywhere, or if I just end up a complete failure who has a whole bunch of videos of him talking to himself. So we'll see, but I'm going to keep on cracking away at this and see if this goes somewhere.